Hello, everyone, and welcome to our first video in the new series, Succeeding in Fourth Grade Math. And today, according to the Common Core standards, we're going to be covering operations and algebraic thinking. First of all, you have to understand how to use the four operations with whole numbers to solve problems. Now, let's look at the first part of this. They want you to interpret multiplication equations as comparisons, okay? So if we looked at 35 equaling 5 times 7, then that statement means 35 is 5 times as many as 7 and 7 times as many as 5, okay? Well, 5 times as many as 7 makes you think, okay, let me just get 7, okay, the number 7, and add that 5 and add that 4 more times, right? So you get 7 plus 7 plus 7 plus 7 plus 7. Same thing with 7 times as many as 5, right? You just get 7 sets of 5, right? So you can have, if you want to visualize it, you can think of 5 candies, right? And you get 7 sets of those 5 candies. And that's going to give you 35. Okay, the second part of this wants you to understand how to multiply or divide to solve word problems involving multiplicative comparison. Okay, sounds a little complex, not too bad though. Let's look at an example to kind of see what they're asking. So if someone asked you, hey, there are 98 pencils in this box, how many are in 3 boxes? Well, all you have to do is go ahead and visualize, understand what they're saying, and then multiply those 98 pencils by 3 boxes, okay, and use multiplication to get 294 pencils. Okay, now you can also use the four operations with whole numbers to solve problems when you're solving a multi-step word problem, okay? And it can be posed with whole numbers and have whole number answers, and it can even have remainders and variables, okay? It's a little more complex. A remainder, as you know, is simply going to be a number that is left over, okay? And we'll look at that in this example here. And then variables, right? Variables are letters that represent what would be numbers. So if I say there are X amount of clothes in, a certain basket, right? That X amount can represent a variety of numbers. It can represent 10. It can represent like 40, okay? Let's look at the example though here. The word problem, as you can see right here, reads, there are 1,723 students in 5 different schools. How many students are in each school, and what are the remaining number of students that don't fit into one of the schools? Okay, well, let's do 5 into 1,723. As you know, you ask yourself, how many times does the divisor 5 go into 17? Okay, well, it goes in 3 times, and it's minus 15 to give you 2. You drop the 2, and 5 goes into 22 4 times, okay? 5 times 4 is 20. Drop the 20 down here, subtract it, you get 2. Go ahead and drop the 3. How many times does 5 go into 23? That's 4 times, right? So we're at 344. 5 times 4 is 20, and then you have a remainder of 3. So 344 remainder 3. So to answer the question, you would simply say there are 344 students in each school, and 3 students don't fit into one specific school. Okay, perfect. Let's go ahead and go on to the next slide here. And it says you have to learn to gain familiarity with factors and multiples. So let's look at the first part here. It says find all the factor pairs for a whole number in the range 1 to 100. Okay, so factor pairs of 14, for example. Let's look at that. So the factor pairs of 14 are 1 times 14, right, and 2 times 7. Those are the only factor pairs that will give you the result for 14. Right? So therefore, the factors of 14 are 1, 2, 7, and 14. And a really important tip that you can keep in mind for factors are think about a number, right? Any number. Let's say we're looking at 14, right? The factors will always only be numbers below or 14, right? So below 14 or the number 14 itself. So it can't be like 16 or 18, right? The factors have to be below the number 14 or the number 14 itself, okay? Let's look at a different example. We're looking at the factor pairs of 37. Well, 37 has only 1 times 37, and that's it. Okay, so the factors of 37 are 1 and 37. And that's it. And that number, 37, is actually called a prime number, okay? And a prime number means it only has 1 and the number itself, right? So if you only have 1 and the number itself, that is a prime number. On the contrary, if you have something like 14, which has 1 times 14 and 2 times 7, that's a composite, which means it has more than 2 factors. In this case, it had 4 factors, right? While prime only have 2 factors. Okay. Now, we should also know how to generate and analyze patterns. This isn't too bad. Uh, the part here says to generate a number or shape pattern that follows a given rule, and then identify apparent features of that pattern that were not stated in the rule. Okay, let's look at what they're trying to say here. So if we're given the rule add 3 and the starting number 1, generate terms in the resulting sequence, and observe the terms appear to alternate between odd and even numbers, that means that you were able to observe something that wasn't explicitly stated. Okay, so what was stated is given the rule add 3 and the starting number 1. Okay, so you say 1, that's an odd number. Okay, add 3, 1 plus 3 is 4, that's an even number. Add 3, 4 plus 3 is 7, that's an odd number. Add 3, 7 plus 3 is 10, that's an even number, and so on, right? We've quickly established a pattern that says, okay, we're going from an odd number to an even number to an odd number to an even number. Okay, and that is pretty much it for today's lesson, okay? I hope you guys enjoyed. Nothing too much, nothing too complex, but what's really important is that you guys just understand how to analyze these patterns, as well as how to use those 4 operations to solve problems. So since that is it, I will see you guys next time in the second unit, and stay safe.